So we're looking at things that are balanced and things that are not balanced. So like if it's balanced, like here, if it's balanced here, it's an equation. If it's not balanced, like here, it would be an inequality. That's all. Like basically, each pink sock is equal to each other. But this small blue sock is less than this bigger sock because it must weigh less. That's why it's out of balance. Okay, so these hanger diagrams are just trying to model inequalities and equations like that. And so when you look at this, it's saying which equation, what's true or false about this. So in diagram A, we have this triangle and it is weighing more. Oh, oops. I just said it wrong about the socks before. It has to be more, or because it must be heavier, or it's heavier and it's weighing it down. Therefore, that sock is bigger. It's greater than this other sock. Which I remember because when I saw it, I was like, that's weird. I would have thought that the little sock is less than the big sock. But maybe it's just it's made out of heavier material or something. Okay, so sorry about that. The pink socks are equal. The little blue sock is greater than the big sock. That's why it's weighing it down. It's heavier. Okay, so that's the same for this one. In this case, what I've written is not true, right? The triangle is not equal to the square. This triangle is equal to these 3 squares. So let me clear that. So if it's pulling it down, it must be way more. The triangle is greater than the square in diagram A. And then in diagram B, the triangle is balanced or equal with 3 squares. So we have a triangle greater than a square for A, or the triangle is equal to 3 times the weight of each square for B. Okay, so we have to read the statements closely. The value of the triangle is greater than the value of the square. Yay, that one was easy because we had already determined that. And it says to choose 3. Choose 3, so 3 of these statements are correct. Okay, the value of the square is greater than the value of the triangle. No, because that's the opposite of what we just said. The value of the triangle is 3 times the value of the square. So that's what over here. The value of the triangle is 3 times the value of each square. Like, if each square was 2, then the triangle would equal 6, which is 3 times as much as 2. Okay, the statement says the value of the square is half the value of the triangle. Well, if that was true, then if the triangle was 6, each square would be 3. So this one's not true. In diagram A, 1 square could be heavier than the triangle. We said that the triangle was heavier because it's weighing it down. So the statement's not right. In diagram B, the triangle could equal 6 and each square could equal 2. Yep, I must have just remembered that because I had made the quiz. All right, so those are those 3. Again, the quizzes, there's more possible points than what it's actually taken out of. Okay, what equation represents diagram B? So I know you guys haven't seen this before other than that video. So let's take a second and look at what it's saying. Right here, there is some unknown quantity that we're representing as y, and then 1, 2, 3. So y plus 3 is balanced or equal to 1, 2, 3, 4, 5, 6. So y plus 3 equals 6. And then the quiz just uses a square to represent the variable. So we want the square plus 3 equals 6. It was the only way that I could do it. Okay, the other options are 6 plus some unknown quantity plus 1, and then 6 equals 3 times that quantity. So the other two options will probably be those. All right, so right here we have 1, 2, 3, 4, 5, 6 equal to 3 times the value of z. You could also write it as, 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals z plus z plus z. But we can then evaluate each expression on each side of the equation, and then 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. And repeated addition is the same as multiplication. We can say that if we added z to itself 3 times, that we can just write it as 3 times z. So that is this one. Okay, I kind of jumped there. So that's my backtracking of what I was thinking. And I think there is one more. What equation represents diagram D? So you have 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals W plus 1. So that is 6 equals W plus 1. Or, in this case, 6 equals box plus 1. Oh, okay, there's 2 more. What value would balance the equation x plus 3 equals 8? So you can think about it this way. You could look at all the options and try them out. If x equals -5, the equation x plus 3 equals 8 would be true. If I do -5 plus 3, if you do that in the calculator, you will get -2. If x is 3 plus 3, that equals 6. We want it to equal 8. If you have 5 plus 3, that does equal 8. And we'll double check that there's not multiple possibilities. 8 plus 3 equals 11. So it is only that option. If you watch the video today, the video talks about a different strategy for doing it. They say, hey, we want to keep this balanced, but we want to just have x by itself. So if I just take away 3 from this side of the scale, it will not be balanced anymore. It would get lighter, right? It would suddenly go like this, and the big 8 would weigh it down. So what we have to do is we have to take away 3 from this side also and do 8 minus 3. So that would give us 5. When you show your work algebraically, that looks like -3 on the left side of the equation and -3 on the right side of the equation. And when we're showing our work, we often put a line there just to show that we're adding or minusing something. What you have left is x equals 8 minus 3, or 5. So that keeps it balanced. That shows our algebraic work. The answer is 5. Okay, and then there's one more. What value would make the equation 12 equals 2 times y true? So again, you could use the same strategy before I tried out each value, or we could look at the picture, or we could do it algebraically. So if I try them each out, it is 12 equals 2 times y. I try out y equals 1. Does that work? 12 equals, oh. Sorry, we so often write left to right. But in math, you don't have to. You can kind of write it how you want. 2 times 1 is 2. It's not that one. What if y equals 2? 2 times 2 is 4. It's not that one. All right, 2 times 6 is 12. So it is that one. And then they had 2 times 12, which equals 24. It's not that one. Okay, so there's that option. The next video that I post later this week will show you how to solve an equation, solve the equation if you're multiplying or dividing. In this case, you need to divide 12 by 2, right? So if I made this into 2 groups, y equals half of 12, or 12 divided by 2, which is 6. So that's another way we could check it. And I just realized I didn't actually write anything at the top. I was just talking. And if I submit it, it's gonna say I didn't say anything. So let's go back and write something real quick. Also my name. I know this is my example. Let's say it's period 3 this time. Keep it even. It says, what do you notice and wonder? I notice that the pink socks are balanced, so they must be the same. They must weigh the same. And the small blue sock is heavier than the big blue sock. So it's weighing down one side of the hanger. All right, that seems like a really good answer, right? It's really long and all that stuff. When I submit it, it's not going to give me any points though, because it's not exactly what I said the answer was going to be. And that's okay. If you wrote something that was good and understandable, I'll just give you the points. And the same thing, let me check how many points it was, but there's more possible points than I took it out of. Oh, internet's probably lagging because it doesn't like that I'm doing a video at the same time. Yeah, so it says I have 8 out of 10, but that's just because it's not automatically scoring that answer. I would have had to write the hangers level when the socks are exactly the same, period. And then it would have scored it right. Or one of the blue socks seems heavier than the other blue sock, period. But you don't have to do that. If you wrote something that was what you noticed and wondered, I gave you the points for it after the fact when I graded it. Okay? I'm also able to give you individual feedback and then email that to you. You just have to look for it. So thank you, everyone. I don't even know how long this was, but I feel like it was longer than 10 minutes. I'll check in with you again tomorrow.